Hi everyone, I'm Erin, Business Development Manager over here at Softree. With me today is Jack Rymack, our Applications Engineer. I'm excited to introduce today's topic in our free Friday webinar series. Today's 30-minute seminar will introduce the quick and easy way to design county roads using RoadEng. It will include creating a terrain model, horizontal and vertical alignments, cross-sections, and earthwork calculations. But before we get going, a couple pieces of housekeeping. First off, we've got you muted. And it's not that we don't want to hear from you. It just keeps our background pretty noise-free. If you've got a question, please ask us in your GoToWebinar question panel. You'll find that located on the right-hand side of your screen. Softree is a proudly Canadian company and a trusted developer of corridor design software for the last 25 years. At the core of our company, and what we'll be demonstrating for you today, is a very user-centric philosophy. Here, we focus on engineering and, more importantly, making easy-to-use software. We strive to stay far away from the steep learning curves that exist in the design software industry. But easy-to-use products doesn't mean compromising on functionality. In today's seminar, Introduction to County Road Design, Jack will be demonstrating the realignment of an existing two-lane rural road based on total station data. In it, he'll be demonstrating how to create a terrain model, how to complete a horizontal alignment, completing a manual vertical alignment, and then optimizing that vertical alignment with our Softree Optimal tool. Finally, creating output sheets. Along the way, he's going to be sharing some useful tips and tricks about our latest version of the software, version 7. Today's demonstration is going to be done in RoadEng, powered with Softree Optimal. It's an add-on tool that exists in our location module. Well, enough from me. Let's head over to Jack and get into the design.
The code is also the feature name, as well as the comments. So if you want to turn any labels on, the labels that will appear will be the codes. Let's just take a look at some of the codes that exist in this file. Most of these codes are point codes, as you can see here. Some of them I've joined into line work, have the software joined into line work. That's not a line code. Let me just find the line code here. Send no. I elected not to change any, join any of these either. I think I've joined some of these. There they are right there. My edge of bituminous left is a line, and there's a few of those, and there's also some on the right side. Same with my edge of flow line left and my edge of flow line right. And you can choose whether you want what color you want and whether it's going to be a break line or not. Just a little definition of what a break line is. For those people that aren't aware, break lines are features that are used in software to stop the tin from crossing them. Great break line features are edge of roads, edge of shoulders, bottom of ditch, top of cut, toe of fill. So any feature where you want your tin to be forced to stop at that break line and not cross it. Let's just import our file, get going on this. Open my file using that import specification that I saved for you. Press OK. There it is. Like Aaron said, it's a simple county road, two-lane county road. I'm going to realign it. Generate my tin and contours. Next step, generate my tin and contours. Minor contour color, change it right here. Major contour color, click on the plus sign, change it right here. black. The top part of the dialog box is your triangles. The bottom part is your contours. Minor contours will be 1 foot interval. Major contours will be 5 foot interval and labeled. If I decide to turn on all triangles, watch what happens. You get these triangles that go across areas where there's no data. You don't want that to happen. Let me just show you quickly how to eliminate those triangles. Let me recalculate my tin contours. Calculate triangles again. This time do not include all, and limit your triangle length to something smaller than including everything. So my triangles will be less than 500 feet long. Let me choose the area where I want to start my design. I'm going to just select this contour right here. Save my file. I'm going to call it countyroad.ter. Okay, just a little recap of what I've done so far. I've looked at how to set up your import specification and imported a data set of a county road. Some of those features were connected into line work, and most of those lines are brake lines. A lot of the features are spot elevation features, so basically just point features. Then what I did was I calculated my tin and contours. Next thing I'm going to do is I'm going to go into my location design module, start doing some horizontal alignment, vertical alignment, volumes, show you how to do some other things in the location design module, some other tips that I have, some other tips that current users might not be aware of, and then do an optimization, a vertical optimization, finally output, and then a drive-through. Let's go on. Module 2 location design. Maximize this. Start out by going File, New. Open up that countyroad.ter. Start at that current point that I selected. So it's got the wrong template in here. It's got a gravel template. I want a rural paved 2-lane highway, county road highway. I'm going to get a set of templates, edit templates. Open up a table. Go into my folder and get a training normal feet. This file, by the way, happens to be in imperial units, feet, and inches. For our Canadian friends, you can design in metric, obviously, but this file just happens to be in imperial. There's my road in there. My cross section has been applied. Next step is to do horizontal alignment. Get a screen layout. Screen layouts are these little files that set up your screen to look like, to have all options turned on that you like to for a specific type task or type of design. For instance, this screen layout is set up to for horizontal alignment. It has a plan window. It has a horizontal curve panel. I'm going to design my my curves to be 40 miles per hour. First of all, I'm going to add in my IPs. I'm going to shade out this background a little bit just because it's a little bit too bright for my liking. That's one little tip that for the people that are not aware of that, you can wash out your backgrounds a little bit more. left click once to add in an IP or PI, go all the way up to that northern part of my county road, left click once again, add another IP or PI right here. I'm not going to go all the way to the end, I'm just going to go about here and just snap to that point. Another trick again is you can snap to features on your design if you want to. The software will snap to those features. You have to have snapping turned on. Let me just show you how to do that. Turn on my snapping. I'm going to snap to that line so that it's right on there. Turn off my snapping now. Put in my assign my horizontal curve. Sorry. Jump back using these buttons here. Once to this IP. Circular curve. I want to have a 40-mile-per-hour curve, and that's going to give me a 600-foot radius with 6% super based on AASHTO tables. And again, just for people that are designing up in Canada, we do have TAC tables built into our software also. These just happen to be AASHTO tables that are, because we are working on an imperial design. Set this as my default curve. Apply, so it will be a 600-foot radius curve with a 6% super. There's my first curve. I set that as my default. Jump back one more, get my default, apply. You can move around your, let me just go up to this northern one. You can move around your IPs if they're not in the right location, and everything will update real time. So all the cross sections between those two locations will update from beginning, from last curve to the end of this design. All those cross sections will be updated. And we're on to vertical alignment now. Let me retrieve my screen layout for vertical. I'm going to show you how to do manual vertical design, and then I'm going to show you the optimizer and how it can optimize your vertical. You can see down here that we have, there's lots of red in the mass hall diagram. That indicates to me that we're wasting a lot. That's because I haven't done any design yet, no vertical design yet. Everything, all my cross sections are just sitting on top of the ground. You can also see over here that we do have a lot of volume being built up, a lot of cut. Approximately 28, almost 28,000 cubic yards of cut. There's no fill at all, almost. Yeah, there's no fill at all. There's only a little bit of fill at the beginning, and basically none after that first little section of road at the beginning. Let me just try to balance this out a bit more. First of all, I'm going to go to my, show you my mass hall diagram and show you some of the colors that will appear. Green is free haul. Free haul is an operable haul. You can set up your distance. I'm going to set up a distance of 300 for free haul. And then there's overhaul, which is also operable, but you'd probably more than likely have to put the earth on a truck and truck it either further along the road or back behind you. Free haul is actually the distance that you can push your earth with your grader or dozer. I'm just going to set this up to a higher distance, 300 for free haul and 1,000 for overhaul. And then we get to the inoperable distances, where you have to actually borrow earth from one location, from either a gravel pit or some other area, maybe another road that you had some excess earth that you can bring in, that you've stockpiled. And also waste is red. So borrow is blue, waste is red. And because you can see there's a lot of waste in this design so far. Left click once, anywhere to the left of that first point, to add in an IP. You can see that the waste started to go down already. Pull it up a bit more and try to get rid of some of that waste. Left click anywhere to the right of that last IP, and left click, and you can see that we're starting to see a little bit more green and yellow. Also, the software puts in a label, a grade label, along your design segments. Left click once, left click again to tie it down. I've got a little too much borrow, so I've got to pull this IP down, or PI. Pull this one down a little bit more too. Left click once, left click again to tie it down, and then finally attach to the end. Before I attach to the end, I'm going to pull one more IP in the middle, pull that down, and then put in my vertical curves, assign my vertical curves. Jump back all the way to the second IP or PI, get my default curve, 40 mile per hour curve. That's going to give me a K value of 54.6 and a length of almost 150, and a site stopping distance of almost 330. I'm going to apply that, set that as my default, jump forward, get my default, apply, jump forward, get my default, apply, jump forward, get my default, apply, jump forward, get my default, apply. All right, I'd like to show you the optimizer now. So the optimizer is another software, like Aaron mentioned, that we developed over the last 5 years in conjunction with UBC, University of British Columbia. It will give you the lowest cost vertical alignment based on constraints and standards that you put into the optimizer. Let me just set up a new optimization. I didn't want to, I just wanted to do this really quickly. I didn't want to spend too much time on this because there are other things that I want to talk about. I'm just going to set up an optimal alignment. Set up the amount of sections that I want. I'm going to turn off all those and just set it up for 30. That's a good number, 155 selected points. Standards. I'm going to do a series of curves and tangents. My minimum curve length will be 150, and that will also be my minimum tangent length. To get a 40 mile per hour curve, I'm going to use a sag of 60 and a crest of 60 for my K. Maintain the 10% grade max and min. Control points. Add in tie my elevation, my starting point down to the ground. You can also tie the end point, but I'm not going to do that. I'm not going to put any pits, but you could put in gravel pits, borrow pits, and waste pits. And I'm going to use my default costs. So this is how the software figures out the lowest cost vertical alignment. It uses earthwork movement costs, cut costs of $12 per cubic yard, fill costs of $4 per cubic yard, hauling costs $8 per cubic yard mile. For free haul, overhauls $4, end hauls $2, and then loading costs 60 cents and $2.60 for overhaul and end haul. I'm just going to use these defaults and just run the optimizer. That's all I'm going to talk about in the optimizer screen. I'm going to set up a process now. Process my vertical alignment. And within a few seconds, you should have a new vertical alignment based on what the software gives you. Let me see what's going on.
So while Jack's just processing that, I'm just going to jump in and mention that Optimal, one of its actual sort of hidden benefits is it is a bit of a feasibility checker. So if Jack's entered in constraints and parameters for the road with both the horizontal and vertical alignments that aren't feasible, so therefore they mathematically cannot exist together, Optimal will actually let you know that and give you a chance to go back, reevaluate your designs to allow it to be possible.
Thank you, Aaron.
Jack, passing it back to you.
Thank you, Aaron. That was one of the error messages that I did see, and I've got it on track now, and it's giving me an overflow of 40 cubic yards. So this is a good sign. So basically, it's telling me that I need to put in a waste pit that will handle 40 cubic yards of material. Let me just go see what my optimal solution is. There's the blue line right there. That's my optimal solution. I'm going to set that as my current. You can see it's quite nicely balanced right now. I wanted to show you one more thing. I wanted to show you how to do a drive-through of this. Oh, no, first of all, I wanted to show output. I'm going to get a screen layout that will set my screen up for plan profile sheets. Set this up so that no, I chose the wrong screen layout. Let me just change my page size. And change my labels. I've got too many of those labels, so I'm going to just turn some of them off or modify them so that I'm not looking at too many cross sections or too many labels. I'm going to turn on 100-foot intervals. Also in the profile window, I'm going to change my elevation, not my elevation, but my scale to 120 vertical, so it's exaggerated, and 1,200 horizontal, and then also change some of those labels. Turn off that, turn on the 100-foot intervals. That looks better. And you can go through all your pages. Let me just do one thing. I seem to have turned off my auto for one of these pages. So basically the software will automatically scroll so that everything goes from left to right. Page 2, page 3, page 4, page 5, page 6, and finally the last page. If you want to have your background turned on, I turned it off, but if you want to have it on, you're more than welcome to turn that back on. Most people do not like to have their plant profile sheets with backgrounds turned on because they want to see the center line, the road edges, ditches, and top of cut toe fill. cross sections. Quickly show you that, and then I'm going to do a drive-through for you. Set up my cross sections so that I'm just looking at 2 by 2, and I want to look at 100-foot intervals like I did before, and you can do bottom up or top down. Pages, 12 pages, you can go through all your pages. You can turn on grids, grid lines. We have grids on, but I can turn on grid lines if I want to. I'm not going to do that, but I am going to do a drive-through for you. I'm just going to minimize this whole thing. File, save as, a terrain file. This is one thing that a lot of our new our existing customers aren't aware of, that you can actually do a drive-through. I'm going to save it as design road. And then I'm going to add some other features in here, like ditches and side slope left and side slope right. And then I'm going to make sure all of these are turned on so that they're brake lines. And then add some more cross sections. I'm going to go over 5 feet, just so that it looks a little smoother when I do a drive-through. There. So now I'm going to go back to my original topo, merge my designed road in. There we go. So basically it was like a cookie cutter. It cut out all the old data in this area. It got rid of all my contours. It does that, but I'll regenerate those back when I do my tin and contours. And then I've got my center line selected, and I'm going to go to my window, new window, graphics, 3D. Set my screen for drive-through flyby. This is a nice little feature that you can actually do a quick drive-through of your design once you've designed it, and present the whole thing in your boardroom in front of all the heads of your organization. I can speed it up so that it's going a little bit faster. Okay, I'm coming out to that straight section. I'm going to do that last curve. And once I get to the end of this, I want to just show you how you can quickly reverse it and then end it there. Oh, it's a nice little feature that you can, for all of our existing users that aren't aware of this, you can do a nice little drive-through of your road. I'm coming close to the end of my alignment. Bang, almost. And then you can reverse play it the other way. I'm going to stop it right here. And thank you very much. That's all I wanted to show you. I will hand it over back to Erin.
Great, thanks, Jack. So to summarize what we saw today, Jack used Rodent to quickly set up a terrain model, create a horizontal alignment, optimize that horizontal alignment, and create output sheets, and then he showed you a couple features with that drive-through. Wanted to highlight a couple upcoming webinars that are going to give a little bit more information on a couple topics that Jack introduced briefly, in particular on February 5th. We've got Designing Outside the Box, Softree Optimal and Corridor Designs. This is a little bit of the science and functionality of Softree Optimal, so that's coming up. And then our next one is on Friday, December the 18th. It's and that's calculating as-built quantities. So I want to obviously thank you all for joining us today. That's it from us here at Softree. Thanks for attending.